One important aspect which we are typically focusing on, even from an exam standpoint, there are a couple of questions that are decently asked on this regression. There is a simple regression, multiple regression. So there are a couple of chapters focusing on this entire aspect. So I thought I can take one practical data set and we can cover this entire story here. Now, regression is more to do with a forecast, right? I would like to forecast something, I would like to predict something based on some other factors. Generally, if I want to forecast, let's say, the price, I may say it depends on some ABC elements, and I need to know what are those ABC elements. And once I know the ABC elements, then I will try to build a relationship between the price and that ABC elements. That equation that gets built is what is the regression equation. I build an equation between a price and let's say in this case I would like to say that the closing price depends on the total traded. Total trades depends on how many trades that are being done. The closing price depends on that. Or probably I would like to say the closing price depends on Nifty. The closing price of Infosys depends on Nifty, or any of this. Probably may be relevant, may not be relevant in the context, but I would really want to say that one variable depends on one or more other variable. Let's say the sales of a company depends on the GDP of the country, the inflation in that year, and various other factors. Now what we need to do in that process is, how is it dependent? What is the relationship between these two? So I would use the mechanism which I can use to find out the relationship between these variables is what is the regression, right? I can simply try to find out the relationship between the two variables. So we'll start off saying the closing price and Nifty. So I'll say closing price of Infosys, or probably I'll call this as Infi itself. The closing price of Infosys is dependent on Nifty, or vice versa, anything. So in that case, this will become the dependent variable and this will become the independent variable. And I can even have multiple independent variables also. I may say the closing price of Infosys depends both on Nifty as well as Sensex, like that. So there could be a single the dependent variable is always one, but independent variables can be either one or more than one. Now the regression will actually create one kind of an equation to typically identify that dependent variable and even use it for prediction purpose, which means if someone says, if I am able to estimate the relationship between Infosys on Nifty and Sensex together, right? So there may be some forecast that is available that by the end of this year Nifty will go to 5,500. If someone gives some forecast, Nifty is expected at 5,500 or Sensex is expected at 18,500, something. Okay, if these are the numbers which are there for the end of December, using my predictability equation, I should be able to predict what should be the price of Infosys at that time. That is what regression is trying to address, right? Regression is simply building an equation between a dependent variable and one or more independent variables, right? So there is sometimes for our exam he may not ask us to do the entire regression process. He will give the regression equation and he may ask us to test whether these variables are significant or not. So there is a hypothesis testing that actually goes on the regression equation. So we'll do both. We'll even look at the predictability part. How do I typically do the regression part, and even the usage with respect to that generated equation. Now first let me generate the equation, then we'll interpret it, and then we can go ahead with each of the independent aspects. So for time being, I'll take Infosys as the dependent variable and Nifty as the independent variable. Alright. So I'll use the regression . Okay, Infosys is the independent dependent variable and Nifty is the independent variable. So based on that, my regression equation actually comes out. Oh, there's some problem with the location. All right. Okay, so this is the way the typical regression equation output comes out. Now, how do I interpret this information? So once we understand all these terms, the typical regression part is more or less done for us. The first thing that comes out here is the regression coefficients. When I say a regression equation, it finally comes in the form of y equal to ax plus b. Any regression equation comes of the form y equal to ax plus b, where x is the independent variable and y is the dependent variable. So probably here it is like Infosys price is equal to some a times Nifty plus b. This is what that comes out, right? And if there are multiple independent variables, it comes out as y equal to ax1 plus bx2 plus c. So x1 is probably Nifty, x2 is Sensex, a, b, c are some constants. That constants are actually derived from your data. The constants are derived from the data using the concept of regression, right? Alright, so this is how the output comes out, and because this output is linear in nature, right? You don't have x squared or something like that, or log x or something like that. You don't have an equation like that, so that's where we call it as a linear regression here, right? Sometimes some variable times x or some constant times x plus b. That's the equation that typically comes out. So going with that here, those are the coefficients. So the constant is typically called as intercept, and the coefficient of that variable is typically a. So when I go with ax plus b, in this, as per this numbers, it comes out to a equal to 0.016681 and then b is 2497.4153. This is the value. Now how are these numbers obtained? Okay, the practical way of looking at these numbers is this coefficient 0.01, whatever it is, this actually comes out with the covariance between the independent variable and the dependent variable divided by the variance of the dependent variable.